Hello everyone. So today we are going to do Leetcode daily challenge house robber. So basically in this question we would be given with an array, and in this array we we are required to have the maximum money, and the second thing is we can't choose adjacent house. So this is the thing which is being written, that it will automatically contact the police if two adjacent houses were broken into on the same night. And we have to do this without alerting the police. So it simply means that we can't choose adjacent houses, and moreover, we are required to have the maximum money with us. So if we choose one, then we can choose only three, or we can choose one. If we choose two, then we can choose only one. So this is the thing which we are required to do here. So in this array, if we choose two, then we can choose either 9, or we can choose either 3 or 1. Or it could be like 2, then 9, and then 1. Or it could be like 2, then 3, right? So it could be any possible combination. But the thing is that we are only required with the maximum money. So this is the thing which we are required to do in this question. So now comes the part that how we would be solving this question. So we can solve this question using recursive approach, and then after recursion, the thing is that here we are given with the constraint that a nums length could be till 100, right? So when it could be till 100, so there could be any number of possibilities. This could even give us TLE, right? So that's why we are required to then optimize the recursive solution by doing memoization, or we could directly use iterative TP. So today I'll be telling you about that how we can do all these three. So for the recursive solution, we have two options. Either we can't drop, as we are given with 2 point that we can't drop adjacent houses, and we need maximum amount, right? So these are two options with us. Now for recursive solution, what we are required is a base case, then options, then recursive relation, and the return statement. So options are that we can either rob the present house, or we can't rob the present house, right? And the recursive relation for these would be, for robbing the present house, we would be simply increment our index with 2 and choose our present house. This is we can do when we are robbing our present house. And if we are not robbing our present house, then we will simply skip the present house and move to next one. That's why we are simply incrementing the index by just 1. So this is how our reconciliation would be like. And at the end, the return statement, as we are required that we need maximum amount, so that's why whatsoever maximum amount we will be getting from rob present or don't rob present, that we will be returning to our answer. Now the base case is, because we are simply incrementing our index, so that's why we need to keep the check that whenever our I is greater than or even equal to nums dot size, then we are required to return 0. So this would be our base case. Now comes the part that how we would be coding this particular solution. Then after coding, I'll try run the code and explain with the recursive tree. So now for coding, we are required with the base case, that is, if our index is greater than equals to nums dot size, then we are required to return 0. I'll explain this base case furthermore. So let's first try with what are the options. So our main is that what are the options, that we are required to rob this or we are not required. So when we are robbing present house, then first in this rob this variable, we'll simply fill with this nums of I means our present element. We'll simply fill in this drop this variable, and then we'll simply call this recursive function in which we are passing our nums array, and we'll simply do index plus 2. And due to doing this index plus 2, we are simply skipping, that is if we are 1, 2, 3 and we have chosen this value. Then if we do plus 2, then we are simply skipping this 1 also, this 2 also, and now we would be pointing at this 3. So that's why we are doing this plus 2, right? And if we are not choosing this present value, then we are not required to write this number here, and we are just required to simply call a recursive function and adding 1 to it, so that it could simply move ahead by skipping one element. That's why we are doing index plus 1. So at the end, as per the requirement of the question, because we are required to turn the maximum out of drop this and don't drop, so that's why at the end we are required to return maximum of drop this and don't drop. Now for this base case, how this comes. So for example, we are given with this array 1, 2, 3, 4. So here is index, then here is index, then here is, and because it is zero based indexing, right? So when even it reaches equals to nums dot size, and here size of num is simply equals to 4, right? So when it reaches this particular index, and also it will work, but when it increases to here, that is it is equals to 4, means our index is equal to 4, then it will simply return 0. Or even if it is greater than nums dot size, because there could be case of I plus 2, then it could means when 3 is there and 3 plus 2 would be 5. So it is simply greater than our 4, right? So at this case also it will simply return 0. So that's why I've taken this base case like this. So before proceeding further, let me show you that how recursive tree would be like. So for this particular question, as we are having two options, either we can drop this or we can't drop this, right? So let me take this simple example only. 1 to 6 is our array, right? So we are having this array 1 to 6 and we have two options, drop this, then we will be choosing our present element and we will be skipping by 2, and if we not choose to drop this, then we will simply skip by 1, right? So we are given with this particular array and we are now at index I is equal to 0 because it is the starting. So we have two options. Either we would be robbing this, so this particular function would be called, that is nums of I plus I plus 2, or this particular function would be called, that is I plus 1, because the recursive tree is so huge. So I have drawn this recursive tree like this. Let me show you that how I have drawn. So basically this is the whole recursive tree which I have drawn. Basically, it is so huge. So I'll be just explaining only one part. So because it would be difficult to explain whole tree. Not difficult, but it will be much more time consuming. So in this only, number of I plus 2, right? So because we are having this number of I and I value is 0, so 1 would be simply chosen. So 1 is here, plus whole array would be as it is copied here. But because it was having I plus 2, so that's why at this particular moment I would be simply equals to 2, right? So again, two functions would be called, that is drop this and don't drop this, right? So at this particular moment, we are having I equals to 2, right? So here I equals to 2, so nums of I, that is nums of 2 would be chosen, that is 1 plus 3. So now we are having 1 plus 3. plus whole array would be as it is copied, and at this point as it was I equals to 2, so when another function which would be called, when this particular would be called, then only when a base case would be hit and it will be returning, then this particular function would be called. So at this particular moment we are not even bothered about this, we are only bothered about this. So number of I would be chosen, so 1 plus 3 would be there and whole array would be copied as it is. Then I plus 2 is here, so that's why 2 plus 2 would be 4. So at this particular moment now our I is equals to 4. So now again drop this function would be called. So here number of I would be chosen, that is number of 4. So number of 4 is here as 5. So now we are having with 1 plus 3 plus 5 and whole array is copied as it is. So now I is simply incremented to I plus 2. So our I is equal to 6. This is equal to the size of the array. So that's why it has now reached the base case. So that's why now it will be returning to its called function, that is to this particular function. And when it returns to this particular function, now it will be calling its don't drop this function, that is I plus 1. At this particular moment our I value was equal to 4, then I plus 1 would be equal to 5. So now I is equal to 5. So that's 5. Now at this particular moment now I is equal to 5. So our uh, whole copy would be simply as it is here copied, that 1 plus 3 plus 2, 4, 5, 6, everything would be copied as it is. Now it will be calling further drop this and don't drop this function. Now when here I was equals to 5, so number of 5 would be 1 plus 3 plus 6, right? But I plus 2 would be done here, so I is equal to 7. So further it won't be called at this moment, then it will be simply returning. And here the answer was 10, so it will return 10 to its caller function. And here I was equals to I plus 1, so it becomes 6. So 6 is simply equal to the size of array. So again it will be returning, and here 0 would be returned. So here 10 is returned to its caller function, and here 8 is returned to caller function. So basically maximum out of both of them is 10. So 10 would be returned to its caller function. So basically in this branch 10 would be returned, and from here whole branch 11 would be returned. So out of then 10 and 11, 11 is maximum, so 11 would be turned to the main caller function. So now here we are having 10, 11, and somewhere from those trees 12 would be returned. So maximum out of all would be 12. So 12 as an answer would be returned. So this is how our whole recursive function would be like. Okay, so we can simply see that this recursion tree is simply so huge, and moreover there are various cases which are being repeated. So for eliminating the case of repetition of so many cases again and again, we could simply memorize this solution. So how we can memorize this solution? Basically, we can simply take a TP array or vector. So here I have simply taken vector temp, right? So in this int what we are passing is the main nums array, and this int temp and our index. So this is the base case same as it was in the recursive solution. So here we are using this memoization. So earlier, if our temp of I is not equals to -1, so we'll simply return temp of I, because what we would be doing is that from our main function we would be simply initializing our temp as equals to -1. That is, all the values in the temp would be earlier as -1 only, but here we will be simply filling up our temp with some values. That's why whenever we hit a case where our temp of I value is not equals to -1, then in that case we'll simply return our temp of I, right? And then now we are having with our main code, that is either we are required to drop this or not drop this. So it is same as it was in recursion only, but at the end another change would be this one in our return statement, that now we would be storing every value in our temp of I, right? So whatsoever value would be there, we will be simply storing in temp of I, and we will be returning that to our function. So this is how we can do our memoization. Basically here I have written I, but here it should have been written as index because I hadn't taken I have taken index. So this was the thing. Now comes the part of iterative DP. Because earlier it was top to down, now it's bottom to up. That is, we would be simply choosing our previous value and we would be simply, as per those previous value only, calculating our further values. So that's why it is known as bottom up DP. So in this bottom up DP approach, how we would be doing is, again we would be taking an auxiliary array which we are naming as DP, and its size is simply equals to the size of input vector, and we are initializing it with 0. Now the value of dp of 0, that is at the index of dp of 0, we are storing with nums of 0 because in the future stages we would be using this particular nums of 0 value. So now the first case is, if our nums dot size is basically our input vector is simply having size as 1 only, then we'll simply return dp of 0. And if that is not the case, then we are simply doing dp of 1 equals to maximum of nums of 0 or nums of I. Means whatsoever maximum is there. Why I've chosen this particular thing here is that if we are having nums equals to 1 comma 2 and we are only required to rob any one of these house, so we'll surely choose this. So that's why I've taken this particular case. Now comes our mean code. So our mean code would be like we would be starting from 2. Why I'm starting from 2? Because we have already filled this 0 and 1, and we in our previous solutions we were doing I plus 2 and I plus 1, right? So that's why I've chosen this I equals to 2. And here as it is bottom up DP, so that's why rather than choosing I plus 2, I would be doing I minus 2 and I minus 1. That's why I've chosen this I equals to 2. So as per that case only, I am choosing present value and I am simply subtracting the index by 2 so that I could have the value which is at 0th index. So at this particular point, dp of 0 plus nums of I, that is nums of 2, would be added up. And in don't, dp of 1 would be added up. But our dp of 2 would be simply having the value of whichsoever maximum value we get out of both of these. So it is somehow similar to memoized only, but here only difference is rather than choosing I plus 2, I'm choosing I minus 2. And the whole process is somehow same only, and I'm doing in the for loop. And at the end, I would be simply returning dp of nums dot size minus 1. Why minus 1? Because it is a zero base index, right? So that's why rather than nums dot size, I will be simply returning nums dot size minus 1 as our answer. So this is how it was being done in the case of iterative DP. So this was all. And regarding the time complexity, so time complexity for both of the memoized and iterative DP will be simply order of n, and both would be having order of an extra space. But if we take the case for recursive solution, then in case of recursive solution, the time complexity is simply order of 2 raised to power n. Why 2 raised to power n? Because we are having two choices, right? So, and for these two choices, we are having n levels, right? So we are n plus n plus n plus n. So it will simply would be equal to 2 raised to power n. So that's why time complexity in this recursive solution is order of 2 raised to power n, and the space complexity will be simply order of 1 because we are not using any extra space. So this was all for this particular question. And the main concern was only about the recursive tree, that how it would be there, because at the starting I was so much confused for doing this. But it is simply like that either we are choosing this or we are not choosing this. And if we are choosing, then we would be simply doing by nums of 5, that is choosing a present element. Then we will simply write that and we will be incrementing with plus 2. That is at this moment our I would be equals to 2, which would be simply used in our next stage. So this was the thing here. But if we are not choosing, that is, if it is I plus 1, then it would be written as it is, means whatsoever which was there at the previous stage, it would be written as it is, but it will again call its nums of I plus 2 function, that is drop this and don't drop this. So this is how this recursive calls would be there in our recursive function. So this was all for it. If you have any doubt about any of the portion, you could ask in comments. So that was all. Thank you.